Hello, everyone. So I'm going to go over problems 33 to the end. Uh, Remember, I already made videos on number 1 to 32. So this should also help you uh, for preparing for the final exam. Now, let's quickly go to 33. In 33, we are supposed to define the following correlations. Now, we did say in class that for correlations, it's always going to go from -1 to +1. In the middle, we have a 0. Now, at -1, we do have a perfect negative, and then at +1, we do have a perfect positive. So -1, perfect negative, and then +1, we've got a perfect positive. Now, what this tells us is that if -1 and +1 are perfect, negative and positive linear correlation, then 0 is a no correlation. No correlation for 0. Now, if the R value is closer to -1, so I'm going to divide this into 4. If it's closer to -1 here, then you're going to say that that is a strong negative. Strong negative. Why? Because it's almost at -1. If it's closer to +1 here, then we're going to say that is a strong positive. Why? Because it's almost at 1 or +1. Now, if it's here, closer to 0, but on the left of 0, that's a negative. So we're going to say that this is a weak negative. So anything from 25% or 0.25 to -0.25 to 0, we're going to say that that is a weak negative. Anything here that is from 0 to +0.25, we're going to say it's weak, but it's a positive. So weak positive linear correlation. And then close to 0.5, we're going to say it's moderate because it's in the middle, kind of, or it's close to the middle. And for negative, it's going to be the same thing. You see it? So if you look at the first one, R equals 0.95, that's a strong positive. Why? Because it's almost 1. It's close to 1. 0.14, oh, that is closer to 0. So you're going to say it's a weak, but it's positive. Weak positive. Weak positive. Now, -0.25, oh, that is closer to 0. It's a weak negative. Oh, -0.91, that is strong negative. It's a strong negative. Why? Because it's closer to -1. So that's how you answer these questions. Now, for 34, 35, we did this in class. If a correlation between two variables is positive, what relationship do the variables have as they change? So with this one, remember we are looking at a positive correlation. Now, if I decide to draw a line this way, from left to right is going up. So this is a positive. This is positive. So because it's going up and because we are saying it's positive, look at the X and Y. As it goes up, you will see that X is increasing, right? It's going up. 1, 2, 3, 4, and then it keeps going like that. So X is going up as this line goes up. And look at Y. Y is also going up. So for a positive correlation, you're going to say that as X increases, for positive, as X increases, Y increases. So both of them do the same thing. X increases, Y increases, which means that as X decreases, Y decreases. So both of them do the same thing. All right. Now for 35, if a correlation between two variables is negative, what relationship do the variables have as they change? What about that one? So again, I'm going to draw. Now from left to right, this line is going down. It's going down. Now, as this line is going down, you would see that what is happening to the X values is that it's going up. X is increasing, but Y is going down and down and down and down and down. So we're going to say Y is decreasing. So as X increases, this is for negative. As X increases, Y decreases. So it's kind of like the opposite. If X decreases, Y increases for a negative correlation. And that's it. That's all we have for that. All right. For 36, that is a definition problem, kind of. Interpolation is when the X values fall within the range that we are looking at. Fall within, that is interpolation. For extrapolation, they fall outside the range of X values we are looking at. Okay. And these are definitions. You could always go back to the solutions and then look at them. All right. Now for number 37, here we're going to be using interpolation, extrapolation. Remember, because extrapolation is outside of the range, it's dangerous, it's inappropriate. Extrapolation is dangerous, and you don't want that situation. Now, look at 37. We create a regression model predicting the height of elementary school kids, Y, based on their age. Which of the following situations is appropriate to use for this model? Now, remember, it says we are looking at the height of elementary school kids. So let's start with A, predicting the height of a second grader. So what you should ask yourself is that if we are looking for we are looking at the height of elementary school kids, is a second grader an elementary school kid? Yes. So that is appropriate. Predicting the height of a ninth grader. Is a ninth grader elementary school kid? No. So that is outside, it's inappropriate. What about a fifth grader? Yes. So that is appropriate. What about an adult? No. It's inappropriate to use an adult. So that's how, you solve these problems. For number 38, again, we are looking at interpolation and extrapolation. If the X values we collect on range from 50 to 75, which of the values represent interpolation and which represent extrapolation? So 50 to 75 is giving us the range of X values. So 32 is the first one. Is 32 within or without? Is it outside or inside? It's outside. So that is extrapolation. B says 54. Is it within or outside? It's within. So that is interpolation. 72, interpolation. 95, extrapolation. And you are done. 95, extrapolation. All right. Now, in 39, we kind of doing the same thing, but in a different way. This time around, we want to predict the values of Y. But we have a regression model, and this is our model. So Y hat equals 3.52x. Now, these numbers here are going to be my X values because it says if X is the following. So if X is 10, I'm going to put 10 in for X minus 12. So this is going to give me 35.2 minus 12, which is 23.2. So I've predicted my Y when X is 10. Now you do the same thing for 15. Put in 15 and then find your y value or your estimated or predicted y value. Put 4 in for x and then solve to get your y hat or your predicted y values. Remember, the answers are at the back. You could always check. Now in number 40, we're doing the same thing, a similar thing. We've got our predicted y value from the problem. So y hat equals 0.813x plus 0.14. We are given the weight of the child, and those are our x values. So y hat equals, I'm starting with the first one, 0.813 times 20 plus 0.14. And this should give us, so you put that in, you're getting 0.813 times 20 plus 14, 0.14. So you're getting 16.4. And then you repeat that for 10 and you repeat that for 17. And that's it. All right. Now, for the assumptions for an ANOVA test, that I'm going to leave that to you. That I'm going to leave that to you. All right. Go to the answers and then read that. And we talked about this in class as well. Now, let's go to 43. Now, in the homework, some of you said it's a lot with the ANOVA, but on the exam, it's not going to be like that. You're going to be given the table. You have the ANOVA table, and then you read the table, and then put the answers in there or choose the right answers. So remember that in class, I told you that treatment is BET, BET, error is W, okay? And then you've got a total. So degrees of freedom for treatment is 2, sum of squares is 134.00000. Mean squares is 67, and then F statistic is 2.279. P-value is 0.1311. Now let's start with the first one. What is sum of squares total, SS tot? What is SS total? So SS total is going to be the sum of squares total, and that is 663.1428572. What is SSBET? SSBET 134.00001. What is SSW? 529.14286. What is degrees of freedom, DFBET? That is going to be 2, right? What is degrees of freedom, W, the error? That is 18. What is the F statistic? The F statistic is 2.279. What is the p-value? You've got it right there, 0.1311271. Then the last one says, if this test was run at an alpha equals 0.05, what will the conclusion be? So our p-value is 0.1311271. And then our alpha is 0.05. Now you could see that p-value is greater than alpha. P-value is greater than alpha. Now, when p-value is greater than alpha, we fail to reject. We fail to reject HO. So the same conclusions as we've done previously. If p-value is greater than alpha, fail to reject HO. If p-value is less than alpha, you reject HO. But here, p-value is greater than alpha. And that is it. So please watch these videos, watch and watch and watch and watch. And the problems are going to be similar. It's not going to be the same. But if you prepare well, I think you should be fine. Thank you so much, and good luck to you on the final. Bye.